Hello everyone. In this video, we are going to talk about how to evaluate definite integrals. So let's talk about the difference between a definite integral and an indefinite integral. So if I have an integration of fx dx from a to b, that's a definite integral in which a is considered to be the lower limit of integration, b is considered to be the upper limit of integration. But if I have an integration for fx dx, that's indefinite integral, in which I don't have an upper and lower limit of integration. So this one is a definite and this one is indefinite. Now, if I have again integration of fx from a to b dx, the antiderivative of the function is usually we use the uppercase f, so it's going to be fx plus c usually when it's indefinite. Where if it is definite, we don't write that, we do f of the upper limit minus f of the lower limit. So what we do basically, we evaluate the definite integral. Once you find the antiderivative, you need to plug in the limits of integration, and so the value of the definite is going to be fb minus fa. Now there are some important rules when it comes to definite integral. So let's look at these rules. The first rule, if I have the lower limit and the upper limit is the same number, so the definite integral will be 0, because the answer should be fa minus fa, and that's 0. Now about this one here, if I want to switch between the lower and the upper limit, I want it to be from b to a instead of a to b, I'm going to take a negative sign out. So they are equal to the negative of the integration from b to a. Now what about if I have a constant? Same as the definite integral, you can take the constant outside the integration. So it will be k, the integration from a to b. Now, if I have a function that sometimes it's very difficult to find the integration from a to c, you can split it, in which you can take it from a to a number in between, and then from b to c. So it will be from a to b, the integration from a to b, plus the integration from b to c. So you kind of split the integration into two parts. Now, what about if I have an integration, a definite integration for two functions, and in between them addition or subtraction? So again, you can split the integration. So you can take the integration from a to b for the function fx, plus or minus the integration from a to b again for the function gx. So now, let me show you the process by which you can evaluate a definite integral. So let's start with this example. The integration of x minus 3 dx from 0 to 2. First of all, I'm going to expand. So it's going to be the integration from 0 to 2, x squared minus 3x dx. And now you can find the antiderivative for each one of these, or you can split, same as when I said the integration of gx, fx plus gx. You can say the integration from 0 to 2 for the function x squared dx, plus or minus in this case the integration from 0 to 2, 3x dx. And since 3 is a constant, you can take it out. I'm not going to do that. I'm going to find the antiderivative for x squared, which is going to be x to the power of 3 over 3, minus the integration of 3x, it will be 3x to the power of 2 over 2. And I will find the different integral from 0 to 2. So remember, it's FB minus FA. So I'm going to say, I'm going to substitute first 2 in these two functions and then subtract F0. So it will be 2 cubed over 3 minus 3, 2 squared over 2 minus 0 cubed over 3 minus 3, 0 squared over 2. We know that this is going to be 0. So here the final answer will be 8 over 3 minus 12 over 2, which is going to be negative 10 over 3. Now for this function here, in order to find the integration, you need to use substitution method. So I'm going to say let u equal x plus 4 du over dx equal 1. So du equal dx. Now you can say the integration 3 over u to the power of 4 and then du. Now the problem for these two, negative 2 to 2, these are basically for x. Now about if I want it for u, I could go here and say, okay, I'm going to substitute x by 2 first time. So I'm going to be u equal 2 plus 4, which is 6. So the upper limit will be 6, my bad. And the lower will be u equal negative 2 plus 4, which is equal 2. So that's going to be 2. So now I have the integration from 2 to 6 in a state negative 2 to 2 because we changed it into u. Now I need to find the integration here. I'm going to take 3 out. And that's going to be equal to 3 u to the power of negative 4. The integration will be u to the power of negative 3 over negative 3. And between 2 to 6, which is basically equal to negative 1 over u cubed from 2 to 6. That's going to be equal to f6 minus f2. That's going to be negative 1 over 6 cubed minus negative 1 over 2 cubed. And that's going to be equal to 13 over 108. Now about this one, the integration for tangent x secant square x dx from negative pi over 4 to 0. First of all, I'm going to use a substitution method. U will be equal to tangent x. Du over dx will be secant squared x. So du is going to be secant squared x dx. So I'm going to go here and say it's going to be 4, and you can take the 4 out. U, and this is going to be du. What about the limit of integration? I'm going to substitute here u by 0 and by negative pi over 4. So that's going to be, first u will be equal tangent 0. That's 0. And u equal tangent negative pi over 4, which is negative 1. So you can say here that's going to be 0 and that's going to be negative 1. Now we can continue. It's going to be 4 u squared over 2 from negative 1 to 0, which is basically equal to 2u squared from negative 1 to 0. And when you substitute now u by negative 1 and 0, will be 2. 0 squared minus 2 negative 1 squared. And that's going to be equal to negative 2. Now in this question, the integration for 1 plus cosine x dx from 0 to pi will be equal to the integration. The integration of 1 is x. The integration of cosine is sine. And that's going to be from 0 to pi. Then you substitute by pi first. So pi plus sine pi minus 0 plus sine 0. That's going to be equal pi plus sine pi is 0. Okay, minus 0 plus sine 0 is 0 as well. So that's 0. So the answer will be pi. So in this question, the integration for 4 sine u over cosine square u du from 0 to pi over 3, we'll notice that cosine, the derivative of cosine is negative sine. So I can say v equal cosine u. Then will be dv over du will be equal negative sine u. And if I put 1 here and I cross multiply, I want dv to be by itself, will be negative sine u multiply du. So I can come here and say, oh, okay, I need negative. So what I'm going to do, I'm going to add negative here, inside and outside. Of course, you can take the 4 out as well. So what I'm going to say negative 4, the integration from 0 to pi over 3, 1 over cosine square u multiply negative sine u du. Now, this is going to be dv, and this is going to be v. So I can say negative 4 integration 1 over v squared dv. Now I need to find v at 0 at pi over 3. So I'm going to go here and say if u equals 0, then v will be equal to cosine 0, which is 1. And if v equal cosine pi over 3, then cosine pi over 3 is 1/2. So it will be basically from 1 to 1/2. Now remember, this number should be less than this one. So the integration from a to b will be equal negative the integration from b to a, right? So what we are going to do, we will say it's equal to negative 4, and then the integration from 1/2 to 1, and I need our negative 1 here. So v negative 2 dv. And that's going to be equal to 4, negative 4 times negative 1 is 4. The integration from 1/2 to 1, v to the power of negative 2 dv. That's going to be equal to 4, v to the power of negative 1 over negative 1. Of course, from 1/2 to 1. That's going to be equal 4, a negative 4 over v from 1/2 to 1. Now we are going to substitute v by 1 and 1/2, so a negative 4 over 1 minus negative 4 over 1/2, and that's going to be equal negative 4 plus 8, and that's going to be equal to 4. So that's, guys, everything about today's lesson. Please let me know if you have any question, and see you in the next video. Bye bye.